I wouldn't normally start a talk like this, but I hope and anticipate that everything I say is going to be wrong. And I think if the centre succeeds in any way, it should be to make this talk as redundant as soon as possible. And what I want to talk about is not really about life at all, but about my hopes and for how arts, humanities, and the sciences can interact in the context of the centre in a really positive way, and in a way I'm really excited about. But my hope is that it blossoms into something which I can't predict now, and hence my expectations are surpassed very quickly. Why I think this is so exciting is, well, has already actually articulated really beautifully by Nick in his introduction to the meeting today, which is that we're really kind of at the birth of a new discipline in some respects. The questions of life in the universe and its origins on Earth have obviously been asked for a very long time. What's really exciting now, today, in looking over the next decade, is the way in which kind of progress in three or more sciences has come together at the same moment in time to allow us to think about integrating them to really address this question in a really meaningful way. And just left to right, I've got an organic molecule. We heard from Matt about the beautiful chemistry that he's doing in his lab and others are doing, synthesizing prebiotic molecules. In the middle, we've got Mars and Venus, just reminding us that we've got these really exceptional opportunities to study planets in the solar system, the prospect of sample return from Mars, potentially missions to Venus to investigate these anomalies in its atmosphere that really point to an exciting decade of investigating the potential for life in our own solar system. And then on the right, obviously, this plethora of exoplanets, which now we heard from Madhu, the exciting, and obviously Sasha as well, the exciting prospects we have ahead of us in terms of looking for biosignatures and signs of life on these planets. So I think what this means is it's a really ideal time to kind of reconceptualize what we mean by asking the question of looking for life in the universe. And that's previously been sort of undertaken in the context of astrobiology as a field. And we may now want to kind of refresh our understanding of what this means. And I think kind of dialogue between the arts, humanities, and the science can really help us achieve this in an exciting way. This is an image that went into the proposal for the Leverhulme Centre and is the kind of vision in the centre for how different disciplines link together. The sciences kind of in the middle here, and they're kind of scaffolded by this framework of arts and humanities activity. And the three kind of highlighted points are challenging traditional concepts and definitions up in the top left, communicating across disciplines, and identifying philosophical and mathematical structures to life. And I just want to touch really briefly on each of these and give my thought, as I said, hopefully wrong and naive thought on how this may work out. And hopefully in a year's time, we can look back and see what's really happened. And it's been so much more than this. But challenging traditional concepts and definitions. I think this is coming back to this picture we've now seen a couple of times of the pale blue dot of Earth. This is sort of the counterpoint in many respects to the terrestrial perspective. It's that obviously we root our exploration in our understanding of Earth, and in many senses our own limitations as organisms that have emerged on Earth. But we need to be mindful of the fact that we're limited maybe in our imagination for what we're looking for. And also in terms of the language we use in kind of framing the problems we're trying to solve. And we've heard maybe a little bit about that already from Carol. So there's things we can think about, kind of words we use kind of quite freely, and maybe with different meaning in different disciplines, that we might want to reevaluate. Things like signal and detection in the context of looking at exoplanets, intelligence and life. What are these things we might be seeking elsewhere in the galaxy? Things to do with prebiotic chemistry, scenario, origin, pathway, and emergence. All of these kind of terms carry a lot of baggage and in some way direct and constrain what we're doing in our experiments. And then plausibility. Plausibility is a big term, I think, and we've heard I think Bayes' theorem mentioned already with some disdain today. But plausibility is kind of clearly a really key concept when it comes to talking about anything, whether it be a signal, whether it be something we do in the lab when we're trying to emulate a natural scenario. Plausibility is this kind of elephant in the room in many respects to the science we do, and it's something it'll be really fun to dig into in the centre. And then finally, habitability. And what this means in the context of what we can understand life to be. The next thing, communicating across disciplines. This is kind of a montage of disciplines that I could think: organic chemistry, biology, earth sciences, planetary sciences, astrophysics, mathematics, kind of threading through all of these. This in and of itself, in bringing people from this diverse range of disciplines into the same room to speak, presents a whole range of interesting, exciting challenges and opportunities. And we already heard from Emily that this is kind of an accidental parallel that our talks have had. This issue, one example of challenges that emerge when you have different sciences in the same room is these definitions we carry around, which actually are different between different groups. And the time zero is kind of a really interesting one. And I think it's interesting not just in the sense that we actually just need to be speaking about the same point in time when we're talking about an event, although that is helpful in getting us all into the room today at the right time, but also in the sense that it's kind of bracketing what we think about, the physical chemical processes we're thinking about, beyond which the negative time, before time zero, we're likely to kind of jettison. And I mean, these are just some things I could quickly think of that we might take as a time zero. We've already heard about Luca today, last universal common ancestor. In some respects, that's kind of a genetic time zero or event horizon, which we can't see beyond. Maybe it's the start of evolution, when prebiotic chemistry transitioned to biology and became selective and contingent in some respects. Earth formation, a geological time zero. Formation of the earliest solids would be a kind of cosmochemical time zero in the context of the protoplanetary disk the Earth was born from. Solar fusion, it may be an astrophysical time zero when hydrogen started being fused in the sun. Or maybe if we go back further, molecular cloud collapse. I think things that happened at all of these times are relevant for the Earth that we have today. So this is just a kind of reminder that definitions like time zero perhaps limit us, and we might want to dig into some of these definitions as a community over the coming years. The final thing is this question of identifying the philosophical and mathematical structure of life. I think this is a really exciting and potentially expansive topic to dig into, but I just wanted to pull out one thread from this, or one angle that we might take in this kind of topic, which is defining progress. And I think in some respects, progress is really easy to define, right? It's the launch of Sasha's mission. 5 telescopes co-orbiting. I thought you were paying for it. I mean, that would be progress, right? A 40-meter telescope is progress. So I think in some respects, more planets discovered is progress. I think in some respects, progress is trivially defined. But I think there's some aspects of the science we do where progress is actually rather more difficult to define. I mean, to be a little bit provocative, some of the experimental science we do, whether it's maths, organic chemistry, whether it's simulating planetary environments in the lab, there's a potential for those to be kind of counterfactual experiments. We don't a priori know that those are simulations of the things that Earth did. We might hope, and we might gain confidence from the outcomes of those experiments that they're simulating Earth, or indeed a planet more generally, but we don't know it to begin with. So there is kind of this sort of slightly unpleasant question of progress that we wouldn't like to dwell on in the context of reporting back to funders how things are going. But one way in which I think that's been tackled by, I guess, a member of our community, John Sutherland, in this really fantastic paper from 2017, this really elegant graph. I don't think John's here anymore, which maybe gives me liberty to speak more freely about this nice graph. But I think this is a really nice attempt to put some words to the idea of progress in the context of experimental sciences. So we're looking at a graph which is charting time or system complexity on the horizontal axis and degree of aliveness on the y-axis. So I think there's like a whole load we could dig into just in this one graph, like the word aliveness. What are we talking about there? Complexity. What does that mean? But what this graph does is make an attempt at charting progress and putting ourselves on it. And humbly, John puts us down essentially almost at the origin, effectively, in this graph. But this kind of effort is kind of an attempt to, I think, speak to the philosophical and mathematical structure of life and tackle this difficult question of progress in fields that are shooting for something quite far off, but need to think about whether they're making progress towards it along the way. So that's all I have to say, and I just wanted to convey my enthusiasm about the prospect for these dialogues over the next years ahead. Thank you.